When the melting it takes place when the temperature increases. When the temperature increases, so the substance absorb heat or take heat. The heat is a type of energy. So when the solid state matter absorb heat, it starts to melt, to change from its solid state to the liquid state. Okay?
Okay.
And we talked about the mass, and we said that the mass doesn't change by changing the state. If we have ice that has a certain mass, when this ice melts and turns to water, its mass is the same. So here the mass is reserved or conserved. The mass doesn't change it by changing the state. It remains the same. Why it remains the same, Sabah? Why the mass remains the same? Why the mass, when we change the state, it remains the same?
Because the weight didn't change.
Yes, the weight didn't change because the particles are the same. There is no particle that is lost. The particles are the same. The particles that is in the solid state matter, which is the ice, is the same as in the water. So the mass is the same. There is no particles that is lost or gained. The number of the particles stay the same. So the mass also stays the same. So the mass doesn't change it by changing the state. Okay? Okay, and we made this activity. Then we will take another process, which is freezing. Freezing is a process which is the opposite to the melting. Freezing here is when the change from the liquid state to the solid state. Like when we have water or juice and put it inside the freezer, this juice or this liquid will turn into ice. This ice is a solid state matter. This process is opposite to the melting process. Okay, so the scientists here call the process or the change of melting a physical change. Why it is a physical change? Because here the properties of the substance is the same. It has the same taste, it has the same color, it has the same texture, but only it changed from the solid state to the liquid state, like the chocolate. If we have a chocolate in the solid state, its color is brown. Its odor is the odor of chocolate. Its taste is the taste of chocolate. When this chocolate, we give it heat or put it on the stove and it start to melt and it change from the solid state to the liquid state. What happened to the chocolate, to the taste of the chocolate? Is it the same or it will change?
The same.
The same. So the taste is the same. The color, it's still brown. So the color is the same and the odor is the same. So there is no change in its properties or in its features. It has the same taste, it has the same color, it has the same odor. Only the thing that it changed is the state. It become more runnier. It become in the liquid state. So we called it a physical change. This change is called a physical because it is only a change in the physical state, only change from solid to liquid, but it have the same properties like the color, like the taste, like the odor. Okay? Okay, what about the freezing? Is the physical change also?
Yes.
Yes, because the chocolate, when it is in the liquid state, and then we put it in the freezer, so it will turn to solid state, but it keep the same properties. It keep its color, it keep its taste, it keep its odor. So it is still chocolate, but what is the change here is only the state, from the liquid state to the solid state, or from the solid state to the liquid state when it is melting. So the melting and the freezing processes, the two are physically changed because the properties of the substance, which is chocolate here, is the same. Okay? The same happens with the ice. The ice is water, but the water in the solid state. Do it tastes like water? Do the ice tastes like water?
Yes.
Yes, it has the same taste. It has the same properties. So the ice is still taste like water. So it have the same properties like the water. The properties of the ice is the same, the properties of the water, but the ice is colder. It's the only change is that the ice is colder than the water, and the ice present in the solid state and the water present in the liquid state. Okay?
Okay.
Okay, so the water and the ice are the same substance. They are the same. They have the same properties. The same with the chocolate. Both chocolate and water have only changed state. So when the chocolate melts to the liquid state, it is still chocolate, have the same properties as the chocolate in the solid state. And when the water freezes and become ice, it have the same properties like the liquid water. They are the same substance. They contain the same type of particles. The particles in the ice is the same as the particles in the water. The particles in the solid chocolate is the same as the particles in the liquid chocolate. They are the same. Okay?
Okay.
Okay. So both chocolate and water have only changed state. For example, they have become runnier. Runnier means that they can flow like the liquids. Become runnier as they can flow like the liquids. Okay?
Okay.
Okay. So freezing or solidifying. Solidifying is to turn to solid. Solidifying means that the substance turned to solid state matter, which is equal to freezing. Freezing is the change from the liquid state to the solid state. Freezing is equal to or has the same meaning as the word solidifying. So solidifying and freezing is the opposite change to melting. Melting is the change from the solid state to the liquid state, like when the ice melts and become liquid water. Freezing is opposite to melting. Freezing here means that the liquid state matter like the water is turned to a solid ice. So we call it freezing, or we can call it solidifying. Okay, Sabah?
Okay.
Okay. The liquid, it changes into solid. This is what the meaning of the word freezing and solidifying, that the liquid water or the liquid stated chocolate is turned into solid state, like solid stated chocolate, or the ice, which is the solid state water. This is also physically change. So the melting is a physically change because it is a change only in the state from solid to liquid. And the freezing, which is opposite to the melting, is also a physically change because it is a change from the liquid state to the solid state. Okay, Sabah?
Okay.
Okay. Can you tell me what is the meaning of the word melting?
Melting, it changes
Yes.
its solid state to a liquid state.
What is the freezing?
A freezing is opposite for the word melting. It changes from its liquid state to solid state.
Okay. Is it a physical change or a chemical change?
Physical change.
Why it is a physical change?
Because it can get its real state again, or it can get melting or freezing again.
Okay, it's reversible. Okay, but the reason that it is a physical change is that the substance have the same properties. The material
Yes.
doesn't change. The particles doesn't change. The particles in the water is the same. The particles in the ice. The particle in the solid chocolate is the same as the particles in the liquid chocolate. So it have the same type of particles, but it only changes the state. So we call it a physical change, which is reversible, as you said. Reversible, that it can be reversed. Okay, we have here an experiment, which is the tools that we need is a plastic glove, water, peg, freezer. What we will do in this experiment, fill a plastic glove with water. We will fill this glove with water, tie the end firmly with a peg, then we will close the end of the glove and we will put a peg Put it in an freezer, then we will put it inside the freezer for several hours. When the water has frozen, carefully peel off the plastic glove. When the water inside the glove is frozen and become in the solid state, we will peel off this plastic glove. We will remove the plastic glove from the ice. Okay?
Okay.
Okay. What do you notice about the shape of the water now that it is frozen? What about the shape of the water? What happened to its shape?
It took the shape of the glove.
Yes, it takes the same shape of the glove. Now it has a fixed shape. Now the shape of the ice is fixed. Why it is fixed shape? It have a fixed shape.
Because it takes its it has fixed shape because
It turned it to solid.
yes, because it turned to solid.
Yes, now the frozen water has a fixed shape because the water now is ice. Ice is a solid state matter. So the ice keeps their shape. They keep their shape because the particles inside the ice here is fixed in position. Its movement is vibrating or shaking in place only. So it keeps its shape. So the water now is fixed in the shape of the glove, like the hand here. It has the shape of the hand or the shape of the glove. It is a fixed shape because it turned it into solid state matter. And the solid state
ألو؟
keeps. أيوه سامعاني؟
كنت سامعة. أيوه.
ده أنا اتكلمت كتير قوي. ما سمعتيش حاجة خالص؟
كنت آخر حاجة أنت قلتي a solid
Yes,
because it turns solid.
it turns into solid. Yes, now the water, which was a liquid before freezing, it was a liquid. The liquid doesn't keep its shape. But when we put it inside the glove and put it inside the freezer, now it turned it into solid. The solid can keep its shape. Why it can keep its shape? Because the particles inside the solid state matter are tightly packed and are close to each other, and they cannot move. They can only move by a vibrating movement. So it keeps its shape. So we will find that the water inside the glove take the shape of the glove and stay fixed in it until it starts melting. Okay? Okay, Saba? Okay. B, which parts of the hand will melt first? What do you think? Which part of this ice or this hand-like shape ice will start to melt first?
The small fingers.
The smallest finger. Yes, very good. Why the smallest finger?
Because it has a small amount of water that will melt first.
Yes, small amount of ice. It's a thin layer of ice. So it will start easily. Will start the first. Okay. Then the second part, the fingers, the smallest finger will melt first. Then all the fingers will start then to melt until we reach this part. This part is the thicker part. The thicker ice. The thicker ice inside this part. So it will melt the last part. Okay? Okay. See, how is this different from the water that went into the glove? How this ice or this shape is different from the water?
Because it has a fixed position.
Yes, it's fixed in its position. The particles are fixed inside its position, while the particles of the water can slide around each other and can flow. So here, this ice have the properties of the solid because the particles inside it is tightly packed together. They are close to each other. They can't vibrate, only they can vibrate in place or shake in place. While the liquid water, its particles can flow around each other. It can be poured, it needs a container. So there is a difference between the properties of the ice and the properties of the water. Okay?
Okay.
طيب. D, is the ice transparent or translucent or opaque? Transparent here that we can see through it, like the glass. The glass is transparent because we can see through the glass. Translucent is partially transparent. We can see in a partially state. It's almost transparent. Okay, يعني نص نص، شفاف نص نص. نص نص ده نقول عليه translucent. Okay, or opaque. Opaque means that we can see through it, like the mobile phone. Can you see through the mobile phone?
No.
Through it, يعني if we put it in front of a thing, we can see what is behind it. So the opaque objects are the objects that we can see through it. Transparent are the objects that we can see through it. So he is asking, is the ice transparent or translucent or opaque? What do you think?
Okay.
Opaque?
Yes.
If it is a thin layer of ice,
Oh, actually, it's translucent.
yes, maybe translucent. In some cases, when the layer of the ice is very thin, it can be transparent. We can see through it when it is a thin layer. But if it is a thick layer, it is maybe translucent, but it is not opaque. Okay?
Okay.
Okay. This property is similar to the water or different from the water. The water is translucent or transparent or opaque. The liquid water.
Water is transparent.
Transparent. So it's sometimes transparent and sometimes translucent. This is the ice. So the ice here and the water have a similar property, which they may be transparent like each other. In some cases, we will find that the ice is transparent. The water also is transparent. So they have here a similar properties because they are consists of the same type of particles. Okay?
Okay.
Okay. Let's talk here. He is asking us to talk about what pattern you observe with the ice melting. What is the pattern or the way in which the ice start to melt?
In hot
Which
weather,
part starts to melt firstly?
the small finger.
Is a small finger. So the thinner the ice, the quickly that it melts, or the thicker the ice, the slower it melts. So as the thickness of the ice becomes smaller, so it will melt easily, or the first part to be melted. And when the ice is thick or have a thickness, high thickness, so it melts the last part or at the end, or slower. It will melt slower. Okay, this is the pattern. That as the thickness of the ice increases, the melting of the ice will be slower. Okay?
Okay.
اوكي الصفحة دي تمام؟
أيوة.
اوكي طيب خلينا نكمل. هيتكلم بقى هنا عن ايه؟ هيتكلم عن البارتكلز. احنا شفنا ال change in the state from the solid state to the liquid state that is happened during the melting process, and the change in the state from the liquid state to the solid state that happen during the freezing process. We want to think about it in the level of the particles. We want to know what happened to the particles inside the liquid state matter and inside the solid state matter. What happened inside it? He is telling me here that the matter is anything that has mass and volume. We know this information from unit 4, that the matter is anything that has mass and volume. Okay, and the matter is consists of small particles. The particles are matter. The particles inside the solid is a matter. The particles inside the liquid is also matter. So the particles are matter, and so are the materials that the particles make up. So the particles inside the material is a matter, and the material itself is a matter. Okay, you understand this point?
Yes.
Yes. The ice, if I have a cube of ice now, this cube of ice is a matter. What about the particles that is inside the ice? It also matters because it has mass and have volume. Okay?
Okay.
Okay. The particles are arranged in different ways in solid and liquid. We know that the particles inside the solid are tightly baked together, are very close to each other. They cannot move, only they can vibrate. What do you think, Sabah? Why they vibrate only? Why the particles in the solid can move only by vibrating movement?
Because it fixes it cannot move from its place to another place.
Yes,
We
why?
need to
Yes, why? It cannot move from its place to another place. Why?
because
Like us, when we have no energy, now I have no energy. I feel that I am tired. So I will stay, or I will stay all the time in the bed because I have no energy. I feel that I am tired. The energy, the amount of energy inside my body is a small amount. So I can't move. I want to stay in place. The same here is for the particles. The particles inside the solid have a small amount of energy. The energy in the particles of the solid is a very small amount. So this very small amount of energy allow the particles to vibrate in place only. It can't move further. It can't leave its place and go to another place because the energy is very small amount inside the particles of the solid. Okay? This is why the particles of the solid stay in place all the time and only can vibrate in its place because it has a small amount of energy. Okay, Saba?
okay.
Right. What about this amount of energy in the case of the particles of the liquid? The particles of the liquid has a bigger amount of energy or a smaller amount of energy?
Bigger,
Bigger, yes. Why?
because it can flow and they can move with itself.
Very good. All
It doesn't want anyone to take to take them and to say to them to move. They move with themselves. They flow.
okay, very good. They have a bigger amount of energy than the particles of the solid. So they can move much more further than the particles of the solid. So they can flow around each other. So it's only depend on the amount of the energy. The particles of the solid have a small amount of energy, so they can vibrate only in place. The particles of the liquid have a bigger amount of energy, so they can flow around each other. They can slide. Slide here need more energy than vibrating. So the sliding movement of the particles of the liquid, because the particles of the liquid have more amount of energy. Okay? Okay, Saba, this is our first rule. تمام؟
Okay.
فاهمة كويس الجزء ده؟ طيب. The particles of the solid, we said that it has small amount of energy. What happens when I will give these particles a larger amount of energy? What they will do?
What will do?
We said that the particles of the solid doesn't move further. They only vibrate in place because they have a small amount of energy. If we give the particles of the solid a more amount of energy or a bigger amount of energy, what they will do? They will move faster or they will move slower?
Oh, I can't hear.
They will move faster or slower if they take a greater amount of energy?
What will gonna flow faster or not?
The solid. انت مش سامعاني من الأول؟
لا ما كنت سامعة ولا حاجة.
طيب هقول تاني. بقولك احنا قلنا ان ال particles of the solid have a small amount of energy. This is cause them to vibrate in place and they can't move further away. What happens when we give these particles of solid a larger amount of energy? They will move faster or they will move slower?
Faster.
Faster, very good. So the particles will start to move faster. When it moves faster, it can slide over each other. These particles, when they move faster, they can slide over each other and stop vibrating. They have now a larger amount of energy. So they will start to move faster and to slide around each other. When they slide around each other, they will turn to liquid. Okay? سامعاني يا صبا؟
أيوة.
سمعتي آخر جزء؟
أيوة.
اوكي، يبقى this is what happened in the melting process. In the melting process, we have a solid. The particles inside this solid have small amount of energy, so they only vibrate in place. When we make heating here means that we give the particle more energy, more heat energy. The heat is a type of energy. When we heat the solid state matter, we give it a larger amount of energy. When the particles of the solid take a larger amount of energy, it starts to move faster, and then it will start to slide around each other or slide over each other. When it starts to slide over each other, so it will change to the liquid state. Okay?
Okay.
Okay, this is what happened inside the melting process in the level of the particles. Okay?
Okay.
It's telling me this here. The particles are arranged in different ways. In solid and liquid, we said that the solid, the particles are neatly arranged together and they vibrate only in their places. In the case of liquid, the particles can slide over each other because it has a larger amount of energy. When a material it changes state, the particle arrangement it changes. So when there is a change from the solid state to the liquid state, we will find that the particles arrangement also changes because the state it changes. We will find that the arrangement of the particles is what gives the solid or liquid its properties. This arrangement of particles, when we talk about the solid, because the particles of the solid are arranged neatly together in rows and columns, this makes the solid keep its shape and cannot flow and doesn't need a container and can be poured. This is due to the arrangement of these particles. In the case of the liquid, we find that the liquid, its particles are not arranged neatly in rows and columns. It's randomly arranged. It can flow over each other. So this causes to the liquid to flow, and they need a container and they can be poured. Okay?
Okay.
Okay. When the state changes, the arrangement of the particles also changes due to the gaining of the energy from heating. He is telling me that for a solid to melt and change into a liquid, something must be happening to the particles arrangement in the solid. To melt the solid or to make the solid to change to liquid, we have to change the arrangement of the particles inside the solid. How we can change this arrangement? We can change it by giving the particles a larger amount of energy so they can move faster and change the movement and the arrangement to the liquid state. Okay, صبا؟ صبا سامعاني؟ صبا معايا؟
Okay. أيوة.
كنت سامعاني؟ ولا الصوت قطع؟
أيوة معاك.
سمعتي اللي أنا قلته ولا الصوت قطع عندك؟
لا سمعت.
اوكي طيب الانرجي دي هنديها للبارتكلز ازاي؟ by heating. So when we heat the solid, when we are heating now a solid or a chocolate, this heating causes the particles in the solid, makes them vibrate faster. So they will start to vibrate faster. If we keep heating, if we are continuing to heat this solid state matter, the particles start to move faster and faster until they can flow around each other. Flow around each other, then they turn it to liquid. Now, as the particles can flow, so they change it to liquid state. They are no longer fixed in their positions. They are arranged more like a liquid. Okay? مفهومة يا سما؟ سما معايا؟
اوكي. أيوة معاك.
الصوت بيقطع ولا ايه؟
لا معاك.
طيب تمام. يبقى ده اللي بيحصل فين يا صبا؟ when there is a changing in the state. بصي لو بصينا على الموديل اللي تحت ده، عندنا موديل اهو. This is a solid state particles. This is the particles inside the solid. They are arranged neatly in rows and columns over each other, and they are vibrating in the place. When we are heating, these particles start to move from its fixed place. It start to flow around the other particles. And then the movement increase as we are still heating. We are still giving the particles energy, more and more energy. The particles start to vibrate faster and faster. And then the particles will start to slide over each other. When it slides over each other, it turns to a liquid state matter. This is what happened in the particles, in the level of the particles, when there is a melting process taking place. Okay, صباح؟
Okay.
You understand this point؟ دي أهم حاجة في الدرس ده. لو فهمتي النقطة دي
أيوة.
خلاص يبقى الدرس تمام. تمام؟
تمام.
تمام. يبقى ايه اللي بيحصل؟ ايه اللي بيحصل in the heat in the melting process? The particles of the solid that are arranged in rows and columns and are very close to each other and only vibrate in place. When we heat them, they start to gain energy or to take energy. This energy causes the particles to start to move faster and faster and to leave their place. When they start to leave their place, they start to slide over each other. When they start to slide over each other, they turn to liquid state. This is what happened in the melting process. تمام يا صبا، مفهومة؟
تمام.
طيب يلا نشوف الايه الاكتيفيتي اللي تحت دي. هو بيقول لي this flow chart models what happens to the particles in a solid as energy is transferred to them by heating. Transferred here, that is given to the particles of the solid. He is asking us to talk about what is happening. Write a sentence to describe what is happening in each image. Use these words. Can you answer it? Can you describe what is happening in each picture using the words here in these boxes? صبا؟ صبا سمعاني؟
أيوة.
أي. سمعتي أنا قلت إيه ولا الصوت راح؟
لا سمعت.
Okay. Can you answer A?
Okay. سمعت. He's telling me what happened to what?
To the particles in the
To the
melting
particles
process.
in solid or
لا
or
solid. Melting is from the solid to liquid. So in the solid.
it take if we have a glove and we put in it a liquid water and we put it in freeze and it come out a solid, the ones will start melting. The first is the smaller fingers because it
Okay.
has the thin.
Okay. I want from you, Sawa, I want from you to describe what happened to the particles in the solid when it is heated and
They
start
are
melting.
moving.
You are now talking about freezing.
They are moving very slowly. They are hitting each other very slowly.
Okay, start by describing the position and the arrangement of the particles of the solid at first.
They are hitting each other. They are actually vibrating very slowly in solid.
Okay, and arrange it in rows and columns. This is a very
Yes.
important part, the arrangement of the particles. The particles here are arranged in rows and columns are neatly arranged and very close to each other and only vibrate in place. Then after we are heating them,
What? After what?
we are heating now the particles of the solid.
After heating them?
Yes?
After heating them,
What happened to the particles?
the particles, if we are heating, the particles, if we are heating them, the particles in a solid to move faster and faster until
Yes.
they can flow around each other.
Yes. Then
They are no longer fixed in their position.
okay. They turn it into what?
They are arranged more. They turn it to a liquid.
Yes. And in the liquid, what are the arrangement of the particles in the liquid?
The arrangement of the particles in a liquid. In an arrangement of particles, it gives a solid or okay. The arrangement of the liquid.
They are not arranged in rows and columns.
They are not
randomly.
arranged. Yeah. Yes.
قول كمل.
They are not arranged neatly in rows. They are arranged like
randomly
they are
arranged.
randomly arranged.
Yes, and they sliding over each other. They can move
Yes.
faster than the particles of the solid, and they are sliding over each other. Okay, this is
Yes.
A. B, have any particles been lost or taken away when the solid melts?
Yes.
The particles are lost or taken from the solid? No.
No.
The
No.
particles
No.
are the same. There is no particle that is lost or taken or even gained. There is no particles is added to the solid, and there is no particle that is lost from the solid. The particles are the same when they are in the solid state, and when the solid state melts and turns into liquid, the number of the particles is the same. Okay?
Yes.
Okay. What happened to the mass of the solid when it melts?
It is the same.
Yes, very good. The mass also is the same. Why it is the same? Because there is no particles that are lost or taken or gained. The particles are the same. The same number of the particles present in the solid is the same number of the particles that present in the liquid after melting. So the mass is the same. The mass of the solid before melting is the same as the mass of the liquid